Hello. So thank you for the introduction. As Alex and said, I'm from the MIT Media Lab and a product designer by training, but now I'm going to be talking to you about some of the computational design tools that I'm working on, and particularly thinking about how we design the future designer's toolbox. So tools have been with us for as long as humanity. Since we first picked up that stone to crack the nut, that's what has been the most significant step that has been taken in human history. The thing that turns animal into man was this step of making tools to a set and regular pattern, was what the anthropologist Louis Leakey said. And the first examples of human design were actually tools, and this has been a part of how we've realized what we imagine into something real for a long, long time. Ever since we had the potter's wheel in Egyptian times. And they can be conceptual. They can just be a flowchart that we can use to as a framework to structure our process, or they can be as simple as the rules of brainstorming. They can be physical, and they can be as specific as this beautiful drawing tool from the 19th century to draw Ionian columns for when they were all the rage. Or they can be as flexible as just clay that you can mold into anything that you want. They can be very, very simple, just like a pen and a Post-it note, or just some paper storyboarding tools so that we can quickly paper prototype mobile applications, or even very, very simple augmented reality tools like this Pepper's Ghost hack with a piece of plastic that just sit on top of your phone, and you can imagine what an augmented reality viewer will look like. Or they can be enormously complex as well. I'm sure we're all familiar with the range of menu bars that you have available on Photoshop. We have robots that are making things. We have AR headsets. We have machine learning that is transforming images that we take on our phones to make them look like Van Gogh painted them. And at the end of the day, tools extend our reach. They are the material and the intellectual extensions that we need to augment our physical and cognitive capabilities. But it's a really important thing that Marshall McLuhan said, he's a media theorist, was that we may shape our tools, but thereafter our tools shape us. And so it's really important to think about how what we design, how we think, how we create is being shifted and changed by the tools that we actually make. And technology really evolves the tools that we make as well. So even just looking at this timeline of the pen, it started off just being a piece of bone that you used to scratch on clay, through to a fountain pen when we wanted it to be more portable, to pencil or different types of pens that you could just draw on walls using new materials. And now we're actually integrating all of that functionality into digital tools. We have ArtRage painting software that actually creates painting almost better than in real life. And actually we're then taking it 3D using VR. This is creating a new type of drawing that we'd never even thought of making before. And so some of the things I'm going to talk about today is how will designers and our tools evolve in this computational future. So I'm going to do this by looking through the different ages of the designer. And so if we just think about what we used to be, it used to be a very artisan industry, where humans designed and craftsmen made. Stradivarius was famous for being able to look at a tree in a forest and be able to hear the sound that the violin could make when he made it. And so all of that was really very much guided by intuition, experience, and the materials. They shaped what we were designing. But then came the age of the industrial designer, where humans designed and machines made. And this was very much about understanding the processes of these systems and automating them into factory lines. And here it was really the materials and techniques of mass production that changed the designs. So the Thornet chair was one of the first industrially manufactured chairs, and then the Bauhaus exploded that in terms of the aesthetic designs that they could create. And thinking about how that relates to computers, actually, this is how intuition started becoming instructions. And from that, instructions could actually become algorithms. So the Jacquard loom, we can actually consider to be the first computing machine, essentially, because it took what was a very human artisan process and coded it into instructions using these punch cards here. And so instead of the human making the pattern, you could program the machine to make the different pattern using that punch card, which is what we know as the beginning of code today. And computational tools that were developed really were about automating that human computation. The first computational CAD tools and CNC milling machines were made at MIT. And it was about specifically programming all of the moves that the draftsmen used to make when they were plotting the XY axis to cut out a wing shape. They then managed to put that onto magnetic tape and have a machine do that, which is what machines are much better at doing, something precise and repeatable. And then that's how CAD came about. So it was about parameterizing all of those draftsman tools as well for repeatability, for precision. And then Ivan Sutherland at MIT as well created the first CAD program in the form of Sketchpad. In 1963, and if any of you haven't seen the Sketchpad video, I would really recommend it. It's astounding at how advanced it was for its time. And so now we have programmatic control of our designs. This is what it's led to. So we have Rhino Grasshopper software that we can start to pull things about. We have self-generating designs using machine learning algorithms such as nervous system and New Balance created a data customized shoe sole based on the gait of your walk. And so it's not just about what do these tools enable as well. We can start thinking about what looks right and how that becomes a ratio. There was the golden ratio, and then we can integrate that into photo app tools that then end up creating the perfect alignment of the images. Colors can become codes. We can have fresh, calming greens that we can then code into numbers that a machine can understand. We have an understanding of how they all interact, and then we can get a tool that helps us pick different color palettes. Typesetting can become a program. We can understand all of the elements of typography and understand them numerically so that we can teach a machine to do that. And then bringing all of that together, then web design in its entirety can become a program. There's slightly controversial software called the Grid AI, which is a website designer, which brings all of that together. It does the layout of the images, it does the color balancing of the images, it does the typography, and once we start teaching these machines all of the mechanics of all of these design elements, that's how we can end up integrating them into these automatic systems. So I would say today that we're in the age of the cyborg designer. We have been cyborgs ever since we picked up that first stone and used it as a tool to extend our abilities. And now, the tools have feedback systems in them, which makes them even more part of our cyborg bodies. And these tools now have computer intuition. And so, AlphaGo, DeepMind now can beat human beings at very, very complex systems. And these machines are beginning to learn from us. So Nest thermostats learn our behavior and then modify their designs, their output to match that. And in terms of design, actually these machines can then help us in our creative process as well. So IBM and Watson worked with an architecture company called Softlab on a project they were making to be inspired by Gaudi's architecture in Barcelona. And they took in all of the images that related to Gaudi's work and also to Barcelona, lots of text based on his work, fed it into the machine learning algorithms, and then highlighted lots of different categories for the designers to take inspiration from. A lot of the categories were very similar to what an expert architect would have come up with, but some of them focused on very little details that they had missed, such as how the tiles here looked a little bit like candy wrappers, which then became a lot of the material quality in the final sculpture. And so these machines can start to help us pick out things that we've maybe overlooked. So in this age of the cyborg designer, computers are designing and machines are making. But what is it that these machines don't know as much? So a lot of these machines know the very numerical language of design. They know the geometries of the objects we make. They know the colors of the objects we make. But designers know the poetry of how we interact with those objects. They know that they know that that's how people will use an iPod, not just the shape and size of what it needs to be. And so part of my own work has been to think about how we can integrate some of these much more poetic, emotional attributes into the very CAD programs that we use. And so this is a project that I did called the Emotive Modeler, which is a plugin for Rhino, where you type in an expressive adjective, and the system will analyze which emotions are connected to the word, and then manipulate the shape of the object to reflect that emotional attribute. And yeah, if you want to find out more, please have a look at that website there. So we can, from integrating these languages into these machine languages, we can then create many, 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 many different design alternatives enormously quickly. And the design opportunities that the machines can create are really very endless. But what is the optimal design? This is a great video that I love. It's called The Last Man's Seat by a design studio called Committee, which thinks about the last man on Earth. What chair design would he make? And he can't decide because what is the optimal design for a chair? And this sort of is a really interesting demonstration to me of the real limitations of what seems like a huge amount of opportunities that these machines can give us, is that, yes, while there are many, many different alternatives that we are offered, what is the right one for that design that you want? And so the key is here, machines are making, but they're making exactly what we tell them to make. And now I want to take a little historical segue and talk about the age of average, which I've been learning about a lot more recently, and I think it's very interesting to think about how it's influenced a lot of the tools that we have today, and whether that's a good thing to be integrated into these tools to be used for creativity. Back in the 18th century, a Belgian physicist called Quetelet he knew a lot about averages because he was a physicist, and that was a very standard mathematical tool to use in their work. But he was also interested in why lots of soldiers were dying in wars. And he was like, right, I'm going to go and measure the humans. So he went and measured thousands of the chest sizes of Scottish soldiers, and then created an average from which he was like, this is the ideal soldier that we have to all work towards. And so this was the beginning of the averaging of the human. And he actually then led that to creating the BMI, the body mass index, that some of you are probably familiar with. So when in the Industrial Revolution, this was then, the idea of the average was exploded, and particularly by a man called Taylor, which some of you might be aware of, who basically invented the assembly line. And he worked with a researcher called Gilbreth, who did lots of motion measurements to really try and understand what is the optimum to move pieces on an assembly line. And it was very much about what is the average speed to do this, and if you fall below, then you're fired, and if you're better, then you're good. So this was really about this optimizing of designing processes, designing these interactions. And then that led into designing for the average. So Henry Dreyfus created this model called the measures of man, which then led into a lot of understanding about ergonomics. And then led into many different ways that we consider how we design physical objects, but has also started to link into how we develop digital interactions as well. And as I've been learning more about machine learning and artificial intelligence, I was very interested and astounded to see at the very core of machine learning is the average. And this is all of the systems that we're using now to optimize all of these decisions, all of these designs that we're making. At the very core of it is the average, which as a designer, where I think about what is not the average, this is a very interesting conflict that I think about what is the role of these systems that use these techniques in these computational tools that we use. And this is part of our lives now, every day. So we're demanding answers from these machines, from Google. We just want an answer from a list of our design questions. And Alexa, we ask Alexa questions. It has to be the right type of question. I don't know whether about you, but Alexa sends me emails telling me what type of questions she wants to be asked, which I find amusing. And these technologies, the machine learning technologies, are being used to quantify different design decisions as well. This is ad hoc image analysis software, which will give a rating on which is the best image for the selection that you want to make for your website, your advertising, whatever. There are image search systems which have only brand-only on-brand filter selection, so that you only see images relating to what is determined to be appropriate for your brand. Which again, is interesting, but is that the direction that we want to be going for these sorts of creative tools? Is that creative? And what was really interesting is that this idea of the average was really debunked in the middle of the 20th century by a researcher called Gilbert, who did a study. So there were 10 dimensions of pilots that people looked at. And the cockpits were designed for these average dimensions, and that was sort of deemed the standard. But he actually did a study where he looked at 4,036 pilots and measured all of them on their 10 dimensions, and not one of them fit every single dimension. And so it was because we are jagged. And so this idea of the average linking into the core of all of these tools is something that I think of is a really interesting conflict that we possibly need to sort of think about being aware of. And I don't know whether this happens to you, but as a designer, this is enormously frustrating for me when I go down the algorithmic rabbit hole, when I'm looking for new information to inspire me, new images to inspire me. And all I see is the same old thing, because these systems learn from me and then they average based on that. And then it just becomes this rabbit hole. I have designer friends who, when they're leading projects with other designers, they ban the use of Pinterest because they end up just having the same images on their mood boards, which then inspire the same designs that they then end up, our sphere of inspiration gets smaller and smaller and smaller based on these averaging algorithms. So a question that I've been thinking as I start to learn more about the potential of these tools is that if we're not careful, are we going to optimize ourselves out of thinking? I don't know about you, but the more that I become involved with these tools, the more and more I'm feeling like the people sitting in the chairs. And when it comes to creativity, this is an interesting quote by a researcher called John Giro, that he said, of particular interest is the creation of new schemas, or rather the creation of entities that appear to cross over the boundaries between schemas. So this is bringing two very different areas and concepts together. That's where real novelty and creativity comes from. And these are kind of silly designs, but they're called chindoku. They're sort of useless product designs that fit in this world of crossing over different concepts. And so, I thought to think about these issues of crossing over schemas in new, interesting ways. And then I think, would a computer come up with this? This is a design of a tree trunk bench by Jürgen Bay, which really was very insightful about human behavior on sitting on a tree stump, but then making it sort of seem like more of a formalized chair design. Or something like this. This is an interesting app by Ekene Ijoma, which is called Look Up. And so he realized that actually there was some interesting data in New York City that there are they do hotspot analysis of where people get into pedestrian car accidents because they're looking at their phones. And so by installing this app on your phone, as you approach these hotspots of attention deficit disasters, then that's how it'll then start to come up with this image to then let you know to look up. And I just start to think about would a computer that was optimizing for whatever come up with these things? So I actually would contend that we are in the age of the industrial cyborg designer, which is still very, very much about optimizing, about analyzing, about quantifying. What is the age of the post-industrial cyborg designer? And what are the tools that we would use in that? What are the qualities of those tools that we need? So this was a very important moment for me in my research. Newsflash, Elon Musk said that humans are underrated. Amazing. It's something that I think about a lot in terms of what are those collaborations that we want with tools in this future that we have? Do we want to make ourselves redundant? Or what are the real key human attributes in the creative process? And one which I've been thinking about a lot is the idea of serendipity in the creative process. What is that sort of true moment of slightly random but purposeful inspiration that's really going to help take your idea to a new place, a new level? And this has actually been thought about a lot in art in the 20th century. Salvador Dali used a process called the paranoid critical method. And it was basically described as limp, improvable conjectures generated through the deliberate stimulation of paranoid thought processes supported by the crutches of Cartesian rationality. So another way to put it is that there is some structure, but how do we integrate serendipity? How do we purposefully find serendipity to make that structure seem more magical, seem more inspiring? And that's something that I think about how can we integrate that notion of serendipity, that real human element in the creative process, into these tools that we make so that they can actually be, as Steve Jobs said, bicycles for our brains. And again, I just want to take another little segue and talk about cybernetics and the art of steermanship. So cybernetics is a Greek word for steering or governance or navigating, and became very popular in the 1950s when Norbert Wiener coined the term in relation to systems dynamics, control theory, etc. And so essentially it's about thinking about a system, and there's inputs to it and output. And what makes it a first-order cybernetic system is that it'll have feedback. So there were some speakers earlier today who started talking about AI and thermostats, and this is the thermostat model. You have an input, you have output, and you have some sort of feedback system to help you navigate as efficiently as you can towards a goal. But this is only a first-order system, because that just will get you to a goal. But it doesn't really consider everything else in the system as well. And one really important moment in the history of cybernetics was when Margaret Mead suggested that we applied cybernetics to cybernetics, and that meant including us in the process as well. So we are the designers designing these tools, designing the designs from the tools. And so how does that, become a looping feedback system again and again and again? And this may seem very complicated, but actually it launches a huge range of interesting questions that we can have about what are those moments of serendipity in this nested system that we can actually enhance for our creativity. And especially as an approach for how we develop tools as well. So this notion of feedback in a nested system is very much like how communication and collaboration works, and which is very similar to design as well. The design process, it's very very collaborative, very communicative. And so cybernetics and design we can also think of as a conversation. And I really think that's a new approach that we can take to our tools, especially these intelligent tools, which are starting to generate and starting to optimize and starting to make design decisions for us. And so I don't know whether any of you have seen this. This is Google Quick Draw, which I love. But you see that as you draw, it'll start to guess what it is you're drawing. And I love the fact that sometimes it guesses many, many, many different things. And from a first-order perspective, because if it was to guess many, many different things, that would be really inefficient. The most efficient thing to do would be that it would guess within one or two feedback iterations, and like, boom, there we go, I guessed that it is a slide. But the interesting approach that we can take for these things is that actually, from a second-order perspective, I'm a participant in this conversation that's happening here. And so I can then start to reinterpret that, those all different interpretations of the drawing, and actually use that as inspiration. So the point I was trying to make was that how can we actually think about these systems and not over-optimizing them? Because the margin of error that they create, if we present it in the right way, even though it may seem nonsensical, they actually may provide a very creative mechanism. So this is Alice in Wonderland discussion with the Mad Hatter, his famous riddle, how is a raven like a writing desk, may seem like nonsense, but actually it's just a creative challenge for those who are minded in that way. And so Kenya Hara, who is a wonderful designer at Moody, he said that creativity is to discover a question that has never been asked. And so this is something that I'm now really interested in thinking about as an approach for how we design these tools in our future designers toolbox. So really specifically, how can we design these new tools for creativity that embrace ambiguity, that wonderful ambiguity and serendipity that humans can really thrive on in the creative process? And how can these tools provide us provocations to consider rather than just give us prescribed answers to our questions? And this is an approach that I've taken in one of the tools that I've made, which is a little tool, as a creative prompt tool, so you can feed in words related to your project, and then it'll start to juxtapose the words in different ways, so that even the most creative designer sometimes gets into a rut about how to juxtapose all of those concepts in new, interesting ways. This is a tool that can actually help to try and do that. And similarly, instead of, if we were to apply this to images, how would instead of just Google, if I was to Google a picture of shoes, instead of just giving me more pictures of exactly the same shoes or exactly the same chair or exactly the same website design or whatever, how could it give me a very different image? And then also try to guide me through different questions, to understand how that could be a mechanism for creative potential as well. Maybe we're thinking of creating a new robotic prosthetic shoe. Or maybe actually we're thinking, all right, how would this shoe, help me get to the moon? Or what would that shoe that was inspired by space travel be like? Or, quite literally, what would a shoe matched with a red herring be like? I don't know whether we have a British phrase being throwing in a red herring, which is the random element. But someone was inspired by that because someone created a red herring looking like shoe. So there you go. Someone found it inspiring. So I just want to end with thinking, a summary of this. What is in the future designer's toolbox? We have shown that we can have the ability to understand from a computational perspective all of the elements of the design process. We can understand how to integrate that into digital tools that almost automate ourselves out of the process. Instead of just searching for the answer saying, machine, design me something so that I can do something else. What if these tools had the approach where they actually helped us reach for the further unknowns that we don't know as a designer, to actively inspire us and provoke us to dig deeper and to link things in new ways that we hadn't thought of before. So, thank you.
Yeah. All right. Thanks.
Thank you. That was an amazing talk.
Thank you.
Yes, certainly conjured up a lot of questions for me. Not sure the right ones, but yeah. So let's move on to Q&A.
We don't have any questions on the question board, but do we have some questions in the audience?
Okay. Maybe while the audience thinks, I'll ask one of my own. So you talked a lot about this weird idea that we humans can combine in very creative ways. And now combining things in general can be very easy. You can do things where you try and compose questions by just taking, I don't know, concepts and saying computer randomly combine. You get a lot of questions, but most of them won't make any sense and won't inspire us to do anything. Have you seen any common guides that are helpful to get to good questions? So what is a good way to find yourself to be?
Well, there are a lot of things called plot generators and computational linguistics and computational poetry, and they analyze different aspects about basically natural language processing, about how to put these things together. But what I find the most interesting is when the questions don't necessarily make sense, but the juxtapositions of interesting concepts is something that's key, and that's how do we figure out what is the right amount of randomness for you, for me. Right. And then also help us to understand how to connect things in new ways as well, because it's actually the understanding of the different concepts that can help you understand how they could be connected in new and novel ways.
All right.
So interesting. I have a question about the average part. It struck me really interesting because I hadn't thought about it that way. And I started thinking, could we turn it around so that we would we know the average, so we consciously make the algorithms avoid it? Is that actually what the end of the talk was about then?
Yeah, we could do that. I don't know whether that would end up working in one way or the other way. I think that, a lot of designers think about on the one hand, on the other hand. You know, we try and find the extremes about things, and so that's one way to quickly start to shift and change these interfaces is to think about demonstrating the extremes. But also I think being able to present this information in a way that has that sort of fuzzy edge of ambiguity rather than the computer dictating to us, being like, this is the answer.
Yeah.
You know, how can we present that interface in that way, which, you know, it could be this, or it could be this, or it could be this, or it could be this.
Yeah.
Yesterday you mentioned Netflix as one of these, that they don't always recommend the average for that person, but also new ones. Is that something that would fit this softer description? Or?
Yeah, definitely. And I think that, so with all of it, I think it just needs to, even with, I don't know about your experience with Netflix, that even if it is recommending things that are not average for me, you get used to the pattern that exists. And so I think the key in that sort of serendipity is also understanding how to shift the pattern so that we're always surprised, always learning something new.
Right, right. Now that we've had a chance to ask our questions, anybody in the audience still that wants to ask something? No? Oh, yeah. Over there. To your left is a microphone.
Okay, hi. Maybe just a kind of notion about like that. How can we insist on going like against the grain in that sense that as a designer or as a kind of like maybe previous designer, now AI person, I've been so many times kind of asked to do and design things that are convenient. And convenience is kind of something that I find a bit disturbing as a goal in general in design. And do you have any like maybe just tips like what kind of discussions to have to go against that grain?
So I would say that when we talk about affordances and convenience, it's often very practical and very functional. But one of the things that I think about, and actually what was interesting about my research into the emotive design tool, was that emotion and aesthetics can be a hugely functional element in a certain context. You know, so a certain aesthetic will make something more functional for a certain person. And so when you talk about convenience, I think it's really important to think about the context in which it's presented. And when we think about seamlessness, even something that is really, really fast and practical and convenient, if it's also not enjoyable, does it seem convenient? You know, time seems a lot longer if you're bored. And so if we're making something not as convenient, how can we make it delightful as well? Or something that you find engaging in that way.
All right. Thank you. Then I think with that question, we're ready to end the Q&A section. Again, give her a warm hand and see you for the next talk.